Welcome to section 3.3 part 2. So these notes can encompass the last 2 pages of the 3.3 notes. We're going to start off with a fun fact. So the derivative of e to the x is e to the x. So this is one of those derivatives where the function and its derivative are the exact same thing. If you want to check it to make sure that I'm not lying to you, feel free to plug in e to the x into your calculator, and then for y2 plug in the derivative, and you will see that their graphs are the exact same thing. So moving on from that, we're going to start with the product rule. So the last section talked about the sum and difference rules, and today we're going to talk about product and quotient. So the product of two differentiable functions u and v is differentiable, and the derivative of u times v is equal to u times the derivative of v plus v times the derivative of u. Or another way that people have shown it is u v prime plus v u prime. So a few examples that we're going to do. We're going to do one example where we find the derivatives, and another example where we use some information about the functions and the derivatives to find a solution. So the first example, we want to find the derivative dy dx if y is equal to 5x squared plus 1 times x cubed plus 3. So first thing we want to do is identify which function is u, which function is v, and then use that to help us. So I'm just going to call the first function u and the second function v. So using that information, we know that we want to set this up as u v prime plus v u prime. So in order for that to happen, we know we want 5x squared plus 1. That's my u. And my v prime would be d dx of x cubed plus 3. And we're going to add v, which is x cubed plus 3, and we'll multiply that by the derivative of u, which is 5x squared plus 1. Okay, now using our rules from part 1 notes, we're going to find the derivatives and simplify this problem. So we have 5x squared plus 1 times, and the derivative of x cubed plus 3. We know that we can use the derivative rule of powers, right? So we know that x cubed is going to turn into 3x squared, and we know the derivative of a constant is 0, so we're left with that. And then when we add, we're adding x cubed plus 3, and then the derivative of 5x squared, right? 5 stays out front, bring down the 2. 5 times 2 is 10. And then 2 minus 1 is 1, so which is 10x. And the derivative of a constant is 0, so we're left with this. Now we can simplify. So we have 15x to the 4th plus 3x squared plus 10x to the 4th plus 30x, which all simplifies down to 25x to the 4th plus 3x squared plus 30x. Okay. So now we're going to use the product rule and some information about u and v to help us find the derivative of y when x is 2. So if we want to find this, we know that y prime is equal to u times v prime plus v times u prime. So y prime of 2, right? We have all of this information about u and v and u prime and v prime at the value of x equals 2, so we're going to use that to fill in these spaces. So u of 2 is 3 times v prime of 2 is 2 plus v of 2, which is 1, times u prime of 2, which is negative 4. So this all comes out to being 6 plus negative 4, which is 2. So y prime of 2 is 2 in this case. So now let's talk about the quotient rule. So the quotient rule is also similar to the product rule in the sense that we have to break down the numerator and the denominator into u and v so that we can use this rule. So at a point where v does not equal 0, the quotient y equals u over v of two differentiable functions is differentiable, and d dx of u over v is equal to v times the derivative of u minus u times the derivative of v all over v squared. Or another way to think about it is v u prime minus u v prime over v squared. Some people like to remember it using this little song, d dx of hi ho is equal to ho d hi minus hi d ho over ho ho. It's just a cute little way some people like to remember it, but it's not necessary. So let's use this example. We want f prime of x if f of x is equal to x cubed minus 1 over 2x to the 5th plus 1. So again, we're going to figure out what's u and what's v. So our numerator will be u and our denominator will be v. And so we know that we want v times u prime minus u times v prime all over v squared. So with that, we know we should have two x to the 5th plus 1 times d dx of x cubed minus 1 minus x cubed minus 1 times d dx of 2x to the 5th plus 1 all over sorry about that, that was my phone. So all over 2x to the 5th plus 1 squared. So I'm going to simplify this just one step. I'm not going to simplify it completely, but feel free to simplify it completely if you'd like to. So we'll have 2x to the 5th plus 1, and then the derivative of x cubed minus 1. Derivative of x cubed will give me 3x squared. Derivative of 1 gives me 0. Minus x cubed minus 1. The derivative of 2x to the 5th is 10x to the 4th. And the derivative of 1 is 0. All over 2x to the 5th plus 1 squared. So that's as far as I'm going to go with this problem. but as you can see, what's left is just multiplication and simplification of these polynomials. If you want to continue with this problem, be my guest, but I'm just going to stop here. I just wanted you to see how to apply the quotient rule to a problem. So now on to this last page. We're going to use the quotient rule to help us identify what is y prime of 2 given all of this information. So just a reminder, y prime would be equal to v times u prime minus u times v prime all over v squared. So using that information, we can identify that y prime of 2 should be equal to v of 2, which is 3, times u prime of 2, which is negative 4, minus u of 2, which is 5, times v prime of 2, which is 2, all over v of 2 squared, which would be 3 squared. And when we simplify that, we get negative 12 minus 10 over 9, which is equal to negative 22 over 9. So sometimes we don't even need to use the quotient rule. We can just use the power rule. So in some cases, such as in these two examples, we can find y prime without having to use the quotient rule. So if you look at number 1, this problem can be rewritten as 5x squared over 6 plus 3x over 6, which can also be broken down as 5 over 6 times x squared plus 3 over 6 times x. And now this problem is just a power rule problem. So we can take the derivative of both pieces and add them together. So in this case, we would have, excuse the baby crying in the background, that's my roommate. We would have 5 over 6 as a constant, and then we have 2x as the derivative of x squared, plus 3 over 6 as our constant, times 1 as the derivative of x. So that gives us 10 over 6x plus 1/2. Which we can further simplify to 5 over 3x plus 1/2. Okay, for the second example, we can split this fraction using multiplication. We can split it as 9 over 5 times 1 over x cubed, and then we can rewrite x cubed as x to the negative 3. So we have 9 over 5 times x to the negative 3. And now we can use our rules for differentiation to help us to differentiate this. So here we have a constant, so we'll pull out the constant 9/5, and then we'll take the derivative d dx of x to the negative 3, which will lead us to 9 over 5 times negative 3x to the negative 4th. And when we simplify that, we get negative 27 over 5 x to the negative 4th. Alright, so the last piece of these notes deals with higher order derivatives. So the cool thing about derivatives is that sometimes you can take multiple derivatives of the same function. So we have y equals f of x, which equals x cubed minus 5x squared plus 2. So if we want to take the first derivative of this function, we just do what we normally do. We would split this up, find the derivative of each piece. So we have x cubed, and the derivative of x cubed we know is 3x squared. The derivative of 5x squared, bring down the 2 with the 5, so we get 10. So we'll have minus 10x. And the derivative of 2 we know is 0. So that's the first derivative. The second derivative requires us to find the derivative of the derivative. So we will find the derivative of 3x squared minus 10x. The same rules that we usually have. So bring down the 2, 2 multiplies the 3, so we get 6x. And then here, the exponent is 1, so we'll bring down the 1, and we get minus 10. And then here we can also get the third derivative. Right, so we can take the derivative of our second derivative. So here, derivative of 6x, right, the exponent was 1, so 6 times 1 is 6. And then the derivative of a constant is 0. So we worked through the first 3 derivatives of the function x cubed minus 5x squared plus 2.